If we ask you to write electron configuration of sodium, we write it as 281, which is okay, meaning it has 3 shells. First shell capacity for 2 electrons, second one 8, and the valence electrons is on the third shell. This here we give you a little bit more description. We talk about energy levels or the main shells, and then it's divided into subshells SP and D and F. And then those are also divided into orbitals, which are regions of space that you probably find those electrons in it. Now each orbital is defined by its energy, its shape, its direction, space. So if you look at 1s2, that's your first shell. It contains subshell S and one orbital which has 2 electrons. And if I try to give you a picture of that, I'm going to put all these dots saying this is possibility or electron density or the orbital 1s that you might find the 2 electrons in it. Then when you go to the second shell, which you used to write as 8, now you have 2 subshells. You have S being repeated, except 2s2, 2s is bigger than 1s, and it encompasses 1s in it. So I'll give you a bigger spherical domain, and we call that 2s, and you put 2 electrons. Now P has 3 orbitals in it. Those orbitals have direction of P sub x, P sub y, P sub z, and each orbital you can put maximum of 2 electrons in it. P sub x looks like a dumbbell, so the edges of dumbbell can come out like this, and I put dots in it to say that's where you might find 2 electrons in it. So this is P subscript x. Then the other 2 electrons will go into P sub y, and the edges of the dumbbell I can show it like this and say this is where you will find P sub y electrons in it. And finally P sub z, which is also degenerate. It has same energy as y and x, and this is where you will find the last 2 electrons of P sub z. Now finally, where is my 3s? It should be a bigger sphere that encompasses the rest. So this is, for example, your 3s. So this here we are going to talk about main energy levels. That's the numbers in front of all those characters. The characters are your sublevels. So each shell is divided into subshells, and we have S, P, D, and F. Now each of these is also divided into orbitals. S has only 1 orbital, P has 3 orbitals, D has 5 orbitals, and finally F that we studied this year has 7 orbitals.